How to harness quantum mechanics to change efficiently information into useful energy. Researchers wonder whether, thanks to knowledge in the field, quantum mechanics will be possible more effectively than before, or completely new method, replace information with mechanical work. Polish physicist presents mathematical tools that this branch of physics, quantum thermodynamics, they will bring you closer to the experiment. Publication by Dr. Kamil Korzekwe from the Jagiellonian University and Dr. Matteo Lostaglio. She received 2 distinctions from the editorial staff of Physical Review on this topic. Letters, one of the most prestigious physical journals on world. Dr. Korzekwe tries to better understand how on the level the second law of thermodynamics works in quantum. This principle, in one of the formulations he says that, a process is not possible whose only effect would be taking a certain amount of heat from the tank and converting it into an equivalent amount labor. A feature of our universe is that entropy, which you can imagine it as a measure of disorder, it always increases over time. Therefore, you cannot order the system, or more precisely, reduce its entropy, without using energy, because at the same time it increases entropy somewhere else. For me, questions about the second law of thermodynamics are questions about a fundamental aspect of the universe. What this law has to do with is that everything comes together, it will spoil, we will all die, everything is heading, according to the arrow of time, towards destruction. The question is why this is so. Also at the level of the laws of physics quantum, says Dr. Korzekwe. The study of quantum thermodynamics also has a more significant dimension: practical. To build more and more efficient machines and get closer, we need devices to the limits that physics puts before us. More precisely, understand her rights. Meanwhile, there are many indications that it is impossible without inclusion in theoretical models of considerations regarding information physics, i.e. physical limitations of its processing. We live in an age of information. And information is not something abstract. She depends on the laws of physics. Also at the mechanical level, quantum and memory-related effects can significantly influence processes. Thermodynamic, says the scientist. And it's about Maxwell's demon. The one proposed in a creative thought experiment would be able to segregate particles into 2 adjacent containers. Opening and closing at the right moment, the partition would be able to collect fast particles in one part, hot particles, in the second one, slow, cold. And thanks to this trick, free build a heat engine. Nice business. But what makes a demon impossible build? The problem is the information obtained by the demon. It must know if the particle that approaches it from a given side is fast, is it free to move the partition at the right time. Information that the demon, it must be obtained and then removed. It is among the hidden costs. And these costs, they make the demon's work not as free as it may seem. Maxwell's demon cannot therefore exist. It would be worth it though develop other quantum trick machines that, e.g., they would allow as little information as possible to obtain as much work as possible. But for now it's far from it, because first there should be a description of how the second one is the law of thermodynamics works in the world of quantum systems. Quantum thermodynamics is the field in which it arises several hundred works a year. Scientists are trying to explain thermodynamics in the quantum level, understand its mechanisms and determine whether it is possible design of heat engines and other devices with efficiency or power bigger than is possible classically. However, I have the impression that in some at that moment, this community started banging its head against the wall. 10 years after its establishment, significant experiments should already appear in this area. We are finally here, physicists, not mathematicians, says Dr. Korzekwe. Our work is about a step towards experiment, provides tools to help with modeling experiments in the field of quantum thermodynamics. We provide formalism mathematical, which is sewn for an experiment. It's like they provided a set of paints, either a hammer and a chisel, adds the researcher. This formalism allows you to describe how particles quantum, by interacting with a heat bath at a given temperature, can move from one state of thermodynamic imbalance to another. And that's how it can be thanks to it, analyze what they are, with some simplifications, all possible future states of a certain system admitted to the environment with a given temperature. The macroscopic equivalent of this experience would be, for example, placing an ice cube in a room at 20 degrees C. Physicists would like to know all possible future states of this system, e.g. dissolved water at 10 degrees C. And thanks to this, look for the future in which the arrangement he will do the greatest work. I want to see how much we can do. Thermodynamically free, without adding energy, comments the scientist. In his opinion, experiments that can be designed using this formalism, they could apply to engines in the long run thermal, which use even work performed by individuals' particles, so-called Szilard engine concept. It's fascinating to understand why time passes in one side. After all, we remember the past, not the future. People started it understood in the 19th century, when the phenomenon of entropy was described. However, since when quantum mechanics has emerged, we know that this is fundamentally not its sufficient explanation. Particles are not billiard balls, but quantum waves probabilities. So will we be able to better understand directionality? The passage of time, if we add the formalism of mechanics to what we already know quantum? Wonders Dr. Korzekwe. An almost invisible solar cell was constructed. Scientists from Tohoku University in Japan constructed transparent solar cell. The transparency of the cell is close to 80% and perhaps it will soon find wide-scale use. Transparent solar cells, TSCs, have recently attracted considerable attention because they can overcome the limitations of traditional once opaque solar cells, Tohoku scientists explain in a paper describing the research, published in Nature Scientific Reports. There have been several rumors about this recently, the upcoming breakthrough in the field of nuclear fusion, but the truth is that we still have a long way to go before this form of energy harvesting takes place more efficient. Before this happens, it is worth looking towards the Sunday. The giant burning ball located in the center of our solar system gas sends 173,000 terawatts of energy towards us. This is over 10,000 times more than total consumption energy in the world. It's no wonder that scientists and designers spend so much time trying to use it. However, there are many factors limiting. Solar panels are usually large, opaque, and often unsightly. Now, a team from Tohoku University has developed almost invisible a solar cell, named NISC. It transmits nearly 80% of light. Theoretically, they can be placed anywhere, from windows in your home to a screen on your smartphone, and even on the skin. We successfully created NISC using ITO, oxide indium tin, one of the most commonly used transparent oxides, conductive, and single-layer tungsten disulfide, as transparent electrodes and photoactive layer, we read in the scientist's work. Using these materials, the team made a solar cell that it beats other transparent cells by several orders of magnitude. The way we formed the solar cell came to fruition: power conversion efficiency over 1,000 times greater than that of the device using an ordinary ITO electrode, explained Professor Toshiaki Kato from Tohoku University's Graduate School of Engineering and co-author of the work. Now scientists are working to increase power conversion and using near cell in solar panels. It's not that simple, because it's not enough to just increase the size of the cell. Must be calculated accurately, what shape and size will bring the right performance. Discoveries can contribute to the development of NISC based on TMD, and their industrial scale production are summarized by the authors of the study.